delta G naught F and delta H naught F for iron that is in gaseous state are 370.7 kilojoule per mole. So the standard gives free energy and a standard enthalpy of formation of Fe gas are 370.7 kilojoule per mole and 416.3 kilojoule per mole at 298 Kelvin respectively. Okay. Assuming delta H naught F, that is the standard enthalpy of formation, is constant in the interval of 250 Kelvin to 375 Kelvin. Okay. So in that interval, we have to assume that delta H naught F is constant. Okay, it is not changing. So what is the value of delta G naught F rounded off to the nearest integer for Fe gas at 375 Kelvin? So basically, what are the information that is given to us? We have given delta G naught F. Okay, standard gives free energy change, that is equal to 370.7 kilojoule per mole, and this is at 298 Kelvin. Okay. Another value that is given is standard enthalpy of formation, that is 416.3 kilojoule per mole, and this value is also at 298 Kelvin. Okay. What we have to calculate? Delta G naught F at 375 Kelvin we have to calculate. Okay. Now, what is the relation between the Gibbs free energy and the enthalpy? The relation that we know is delta G naught F equal to delta H naught F minus T delta S naught. That is standard Gibbs free energy change equal to standard enthalpy of formation minus temperature into entropy change. Okay. If we use the formula at 298 Kelvin, okay, what are the information we have? Delta G naught F value we have, that is 370.7 kilojoule per mole, equal to delta H naught value is 416.3 kilojoule per mole minus temperature 298 Kelvin, because we are using this equation at 298 Kelvin. Okay, so we'll keep write like this into delta H naught. So first we'll find the entropy change, and that will be 416.3 minus 370.7. It's a simple calculation divided by 298. And simply if you do it, we'll be getting approximately 0.153 kilojoule per Kelvin. Okay, that is the value of entropy change. Okay. What we have to calculate? Delta G naught F at 375 Kelvin. So again we will write the same equation. Okay. So we can say at 375 Kelvin, we'll write the same equation, that is delta G naught F at 375 Kelvin is equal to delta H naught F at this temperature, okay, minus T, temperature must be 375 into delta H naught. Okay. This value we have to calculate, okay, at 375 Kelvin. So no need to write now, it is understood. Okay. Now what is the value of this delta H naught F? Since in the question it is given that this delta H naught F value is constant in this interval. Okay. So this value is not changing. Okay. So it will remain as 416.3 kilojoule per mole minus temperature. Now it will be 375 Kelvin into delta H naught. And delta H naught value already we have calculated. What is the value? It is 0.153 kilojoule per Kelvin. This delta H naught value, that is 0.153 kilojoule per Kelvin, is at temperature 298. This value is at temperature 298. But the same value we will take because entropy change is also the function of what? Enthalpy. And since enthalpy is not changing in the interval, so entropy will also be constant. That will also not change in that interval. And we have to keep the same value here, that is 0.153 kilojoule per Kelvin. And if we are putting it, will be simply 416.3 minus 325 into 0.153. That is the value. Okay, kilojoule per mole. And now simply we have to solve it. After solving, we'll be getting 358.91, okay, kilojoule per mole. And since in the question it is given that we have to round off to the nearest integer, so the nearest integer is 359, okay, and that is the final answer. So that is 359 kilojoule per mole is the final answer. Now if you see, the correct option will be option A. Okay. Now if you see your comments, then Rahul Bhattacharya has got exactly the correct answer, that is 359 and option A.